Hi everyone, I'm Cheryl. In this problem, we're asked to find the indefinite integral of a vector-valued function. Well, in order to find the indefinite integral, we're going to find the integral of each of the individual components. So let's rewrite this as the integral of 1 over t dt times my vector I plus the integral of 1 dt times my vector j minus the integral of t to the 3/2 dt times my vector k. Okay, now looking at these one at a time, I have the integral of 1 over t dt. We know that that's the natural log of the absolute value of t plus a constant. We're going to call that c1. And we'll take this and we'll multiply our result by vector I. Moving on, we have the integral of 1 dt. That's going to be t. And again, we have a constant of integration. We'll call it c2. And we multiply that result by my vector j. And for the third component, I'm going to have the integral of t to the 3/2 dt, which is going to be t to the 5/2 divided by 5/2, which is the same thing as multiplying by 2/5. And again, I have a constant of integration. C3, I'll call it. And this is multiplied by my vector k. Now, if I rearrange terms a little bit, I can write this as the natural log of the absolute value of t times my vector I plus t times my vector j minus 2/5 t to the 5/2 times vector k plus all of my constants. So this will be plus c1 times vector I plus c2 times vector j plus c3 times vector k. Notice that my constant turned into a constant vector. So my answer looks like the natural log of the absolute value of t times vector I plus t times vector j minus 2/5 t to the 5/2 times vector k plus my constant vector. Now, with a little practice, you'll be able to go straight from the original integral to this result. One more thing. If you take a look at your original vector-valued function, I noticed a couple of things. First of all, in my first component, I have 1 divided by t, which means t cannot equal 0. And in my third component, I have t to the 3/2 power. I'm taking the square root of t, which means that t has to be a positive number. So when I look at my final answer, this absolute value of t is not necessary. I can, if I wish, write my answer as the natural log of t times I plus t times my vector j minus 2/5 t to the 5/2 times vector k plus my constant vector. I hope that was helpful. Thanks.